Welcome back to the deep dive. So, you're fascinated by AI, right? It feels like it's everywhere, changing things quietly, but sometimes it's buried under all the jargon. If that sounds like you, you're definitely in the right place today. We're going beyond just defining AI. We want to peel back the layers, understand what's really driving things forward, and what it means for you. And I'm really excited to have an incredible guide with us to help navigate all this.
It's great to be here. Yeah, the AI world, it just moves so fast, doesn't it? I'm really looking forward to helping everyone, get past the headlines and understand a bit more deeply what's actually happening.
Perfect. Okay, let's just dive right in then. When we talk about artificial intelligence now, it feels different from the old sci-fi stuff. For our audience who are pretty tech savvy, how would you describe where AI is now? What does intelligence even mean for a machine today?
That's a really crucial point. Modern AI, at its core, isn't really aiming for, human consciousness, not at all. It's more about building computer systems that can get really good at specific tasks that usually need human smarts. Things like learning from data, making predictions, spotting complex patterns, even creating new text or images. So think less about conscious robots, and more about systems that mimic human abilities. But they do it with incredible speed and scale, often, honestly, better than humans in very specific areas. The real cutting edge now is about performance and adaptability, not consciousness.
Right, the distinction mimicking versus actual consciousness, that feels really important for sidestepping the usual confusion. So when you talk about these really sophisticated abilities, what's an example maybe we encounter daily that's AI, but maybe not obviously AI, something beyond, say, just a smart speaker?
Okay, well, think about your ride-sharing app, how it figures out the price instantly or finds the best route for the driver, even with traffic changing all the time. That's a really complex AI calculation happening behind the scenes. It's constantly looking at demand, traffic, weather, where drivers are, balancing it all.
Oh, okay.
Or think about personalized medicine. That's a huge area. AI is starting to analyze genetic data, patient history, to suggest treatment plans tailored right down to the individual, predicting maybe how effective a certain drug might be for you. That's way beyond a simple spam filter.
Wow, okay. Those examples really show how complex this hidden AI is, just shaping our everyday stuff. It's also fascinating how long people have been thinking about this idea, artificial intelligence. I know there's a history there. Can you maybe tell us a bit about where the actual term artificial intelligence first came from, and how does that original idea stack up against what we see today?
Yeah, it's pretty amazing how long the dream has been around. The term itself, artificial intelligence, was actually coined way back in 1956. There was a summer workshop at Dartmouth College. That's where it started.
1956. Wow.
Yeah, over half a century ago. Back then, the vision was mostly based on what we call symbolic AI. The idea was you could build systems that reason by manipulating symbols, kind of like programming logic directly into the machine.
So like hard-coding the rules of thinking.
Pretty much, yeah. And it had some success, but modern AI, especially with machine learning taking off, it's shifted dramatically. It's now very much data-driven. We've moved from trying to tell the machine exactly how to think step by step to showing it just massive amounts of data and letting it learn the patterns and how to make decisions itself. It's a totally fundamental shift.
That shift from explicit rules to learning from data, that's huge. And it leads us right into, the engine behind so much of today's AI. We hear machine learning constantly. How does machine learning specifically underpin all these breakthroughs? What makes it so powerful compared to those older ways?
Machine learning really is the powerhouse of modern AI, no question. Its big strength is finding these really complicated relationships, these hidden structures in tons of data, stuff humans might miss, or data that's just too complex, too high-dimensional. You see, unlike those older systems where you had to code every single rule, machine learning algorithms adapt. They get better as they see more data. It's kind of like teaching a child, You don't give them a rule book for recognizing a cat. You just show them lots and lots of pictures of cats.
Lots of examples.
Exactly. Until they just get it. The algorithm figures out the underlying principles on its own and can then apply that to new things it hasn't seen before.
That makes total sense, especially with the sheer amount of data we have now. It'd be impossible to write rules for everything. Now, within machine learning, we often hear about supervised and unsupervised learning. Our audience probably knows the basic difference, but in the real world, what are the trade-offs? When do you choose one over the other? What are the challenges?
Yeah, that's where it gets really practical. So supervised learning, that's when you have labeled data. You know the right answer for your training examples. It's fantastic for things like, say, predicting house prices based on size and location, or classifying images if you've already labeled them cat or dog.
Because you're supervising the learning with the answers.
Precisely. But the big challenge, getting that labeled data, it can be incredibly expensive and time-consuming. Think about medical scans. You need expert radiologists to label them. That doesn't scale easily.
Right, the labeling bottleneck.
Exactly. Now, unsupervised learning that works with unlabeled data, which is everywhere, way more abundant. It's great for finding hidden patterns or grouping things without being told what to look for, like finding different customer segments based on how they shop, or spotting unusual activity like fraud.
So it discovers the structure itself.
It does. But the trade-off there is often interpretability. It might find clusters, but it can be harder to know exactly why those things are grouped together. And for critical decisions, you often need to understand the why. So that's led to newer approaches too, like semi-supervised or self-supervised learning, trying to get the best of both.
Okay, so it's a constant balance between data availability, the task itself, and how much you need to understand the model's reasoning. Makes sense. Beyond machine learning, though, what other key areas are really pushing AI forward? And are they starting to work together more?
Oh, absolutely. Machine learning is huge, but not the whole picture. We've got natural language processing, or NLP. That's seen just an explosion lately.
Right.
We're way beyond basic chatbots now. Think large language models, LLMs, built on things like transformer architectures. They can understand context, generate really creative text, summarize long documents, even write computer code. Processing language like this opens up so much.
Yeah, the LLM progress is kind of mind-blowing.
It really is. Then there's computer vision, giving machines the ability to see and interpret images, videos. It's not just facial recognition anymore. We're seeing AI create incredibly realistic images just from text descriptions. Or think about self-driving cars. Their perception systems have to understand incredibly complex, fast-moving scenes in real time. That's advanced computer vision. And, of course, robotics. We're putting AI brains into physical bodies more and more, moving past factory arms, doing the same thing over and over, towards robots that can actually interact smartly with the world. Maybe learn new skills by watching, or even work safely alongside people.
And you mentioned them working together.
Exactly.
Yeah.
That's the really exciting part. These fields aren't separate silos anymore. An advanced robot, it needs computer vision to see, maybe NLP to understand instructions, and machine learning to adapt its movements. It's this convergence, this combination of capabilities that's really unlocking the next level of AI power.
That convergence. Yeah, that sounds like where the really game-changing stuff happens. Thinking about that bigger picture, what's maybe a surprising impact or a future use of AI that you think people aren't fully appreciating yet?
I think one of the most profound, maybe less flashy impacts is AI's potential to just supercharge scientific discovery and engineering. Imagine AI systems that can analyze, say, billions of potential drug molecules to find promising candidates for diseases, way faster than humans ever could.
Right, accelerating research itself.
Exactly. Or AI designing brand new materials with specific desired properties, maybe for better batteries or solar cells, predicting how they'll behave before we even try to make them in a lab. It's not just about making existing processes faster. It's about changing the speed and the scope of innovation itself, enabling breakthroughs that were just, frankly, out of reach before.
Wow. Moving beyond just optimization to actually driving invention.
Yeah.
That is a profound shift. Okay, so for our listeners, many are probably already following AI. Maybe they've done some online courses, played around a bit. If they want to go deeper now, move beyond those beginner tutorials, what would be your top recommendations? How do they genuinely level up their understanding and skills?
That's a great question. My main advice would be try to move beyond just using the tools, like, say, prompting an LLM, and start digging into their architecture. How do they actually work? What are their weaknesses? So with LLMs, maybe look into attention mechanisms or learn about fine-tuning or understand the real problems with things like hallucination or bias.
Get under the hood a bit more.
Exactly. And maybe don't shy away from the math foundations entirely. Not to become a pure mathematician, but understanding some linear algebra or calculus in the context of how neural networks learn. It just gives you a much deeper intuition for why these models work the way they do. It unlocks another level of understanding.
Okay, so moving from user to, let's say, a more informed practitioner, are there specific skills or areas you'd suggest focusing on right now for that next leap?
Yeah, definitely. Understanding data pipelines and data engineering is huge. Models are useless without good, clean data. So knowing how to manage and prepare data is critical. Exploring more advanced deep learning areas could be valuable too, things like GANs, generative adversarial networks, or reinforcement learning. They open up different kinds of problems. And crucially, I'd say, try to build something. Don't just consume models someone else built, even if it's small. Can you take an existing model and fine-tune it for a very specific task you care about? Can you try to implement a technique you read about in a research paper?
Get your hands dirty.
Absolutely. That hands-on struggle where you hit real problems, debugging, optimizing, figuring out why something isn't working, that's where the best learning happens. It's invaluable.
That makes a lot of sense. And what's really helpful now, isn't it, is that so many powerful AI tools and libraries are actually open source. They're free to use. It feels like access to really cutting-edge stuff has been democratized compared to even a few years ago.
Oh, completely. The open source AI community is incredibly vibrant. It's a massive advantage for learning. It means you can download and experiment with state-of-the-art models. You can look at their code. You can even contribute back to projects if you get skilled enough. You can learn from experts all over the world, often without needing, a huge budget or access to a massive university lab. It's really changed the game for accessibility.
Yeah, that collaborative energy is pretty amazing.
It really is. And the satisfaction you get when you finally build your first model that actually works, maybe predicts something accurately or generates something cool, or even just getting a complex piece of code from a research paper to run correctly. It feels like solving this incredibly intricate, fascinating puzzle. And the possibilities feel kind of endless.
That's a fantastic way to put it. It really captures that excitement of creation and discovery in this field. Well, thank you so much. This has been incredibly helpful, genuinely. You've really helped make the current AI landscape much clearer, I think, for everyone listening.
It was absolutely my pleasure. Happy to talk about it. I guess my final thought for everyone listening would be, just remember that AI isn't static. It's not just a set of tools you learn once. It's this incredibly fast-moving frontier. It's changing industries, it's changing science, it's changing daily life, often in ways we don't even notice yet. The real excitement, I think, isn't just in what AI can do, but how it forces us to rethink intelligence itself and how we solve problems. So stay curious. Keep exploring. Don't be afraid to dig into that next layer. Every little bit you learn unlocks more understanding.
Brilliant advice. Stay curious. Absolutely. And for all of you listening, we will have links to some of the concepts and maybe some resources we touched on today in our show notes so you can explore further. Thank you so much for tuning in to this deep dive, and we'll catch you next time for more insights.